Hey, I'm Adam. This is the Machine Tech video blog, and today I'd like to talk a little bit about anti-friction bearings. Bearings are essential components in all rotating machinery. And when I say bearing, I mean any device which does the following three things. 1. Bearings minimize the friction between contacting surfaces. 2. Bearings restrict the motion of rotating components inside of the stationary component, like a casing. And 3. Bearings support the loads imposed on the shaft. Let me show you what I'm talking about. Hopefully you noticed by the way that this pump is set up. We have a stationary casing, and we have a rotating shaft that runs through it, and on either side we've got bearings. Notice the bearings usually come in pairs. Depending on the application, you could have more than 2, but you always need at least 2. Now, this is the shaft that we pulled out of the pump. Imagine that this is rotating inside of the casing. Everywhere where we have relative motion between surfaces, there's going to be friction generated. Whenever you have friction, you have heat. Whenever you have heat, you have wear. So we need some way to mitigate that. Secondly, this shaft is essentially free to flop around inside of the casing or even shoot out the backside if it wants to. We need some way to restrict the motion of the shaft inside of the casing and locate it. And the third thing is that the shaft has many forces acting on it, whether it's from hydraulic imbalance in the impeller, it's a bent shaft, it's mass imbalance, whatever it is, we need some way to support that load. And there are essentially two different kinds of loading. There's radial loading, which is 90 degrees perpendicular to the shaft axis, or there's axial loading, which is parallel to the shaft axis. And how much and what type of load you have acting on your shaft is going to decide what kind of bearing you're going to use. Now let me be clear. There are two main categories of bearing. On the one hand, you have the hydrodynamic bearing, which is really nothing more than a sleeve with some lube in it that a shaft spins around in. Then you have the category of bearing that most people think about when they hear the word bearing, and that's the anti-friction bearing. Anti-friction bearings use rolling contact rather than sliding contact. Rolling contact has a lower coefficient of friction, or drag, and that's where anti-friction bearings get their name. Now, there are enough differences between the two categories of bearing that they really deserve their own episodes. We'll deal with hydrodynamic bearings at a later date, and today we'll just focus in on the anti-friction bearings. All anti-friction bearings have the same 4 basic components. First, you have an inside ring called an inner race. Second, you have an outside ring called an outer race. The races are usually made out of alloy steel, which has been case hardened so that it's hard on the outside but tough on the inside. They're machined, ground, lapped to extremely fine tolerances and surface finishes, which is essential for the functioning of the bearing itself. Inside the rings we have grooves, and inside of the grooves we have our rolling elements, which is number 3. And the fourth and final thing that you absolutely need in an anti-friction bearing is some way to evenly space the rolling elements inside of the races. This is called a separator or a cage. Now, just like when you go to buy a car, this is the base model. Your bearing manufacturer might want to upsell you on some options. These extra accessories, usually in the form of seals or shields, are really about protecting your internal components from the hostile outside world, which is filled with dirt and grime and all kinds of nasty things. This is the bearing I've been using as an example. Because of its symmetrical design with a single deep groove for ball-type elements, this type of bearing is called a deep groove radial ball bearing. As the name suggests, it handles a good amount of radial load and some axial load. It's a good all-around bearing and therefore is the most common. You'll often see them in electric motors or pumps. For added load supporting capacity, these bearings, and many other types for that matter, also come in double row configurations, which have 2 grooves and 2 sets of rolling elements inside the races. Here's the same type of bearing, but notice that whereas the first bearing has a cage made out of stamped steel, this one has a cage made with polyamide, a type of synthetic polymer. Here's the same bearing again, but notice the metal shield protecting the bearing elements. This is one of those optional accessories I mentioned. The other type of common bearing protection is the elastomer seal. Both shielded and sealed bearings are pre-filled with grease at the factory and are considered lubricated for the life of the bearing. The angular contact ball bearing can support a large amount of thrust load because of its asymmetrical design, which features a high groove shoulder on one side of the inner race and a high groove shoulder on the opposite side of the outer race. However, the design also means that this type of bearing can handle axial load in one direction only. That's why these bearings are typically used in pairs arranged back to back. Notice also that these bearings feature yet another type of bearing cage material, machined brass. Along with ball-type elements, there are also 4 roller-type elements used in anti-friction bearings. Unlike balls, which contact the races at single points, rollers of all types contact the races along their entire lengths. The increased line-shaped contact area means they can handle significantly higher loads. The cylindrical roller bearing can support exceptionally high radial loads. However, it has almost no thrust load supporting capacity because rollers are not designed to contact the races on the end faces. Needle roller bearings are similar to cylindrical roller bearings, but their high roller-to-length ratio gives them more load-supporting capacity in a smaller package. They're often used when space or weight is an issue. Tapered roller bearings solve the problem of poor axial load-supporting capacity with tapered rollers that fit into conical races. Although in this case, as with angular contact ball bearings, the axial load must be in one direction only. The ability to handle good amounts of both radial and axial load, as well as a high degree of accuracy and rigidity, make tapered roller bearings ideal for applications like machine tool spindles. The spherical roller bearing is designed with barrel-shaped rollers that ride in a curved outer race. Their heavy-duty double-row construction makes these bearings capable of supporting the greatest amount of both radial and axial load, and they can handle a good deal of shock or impact load as well. The inner race and rollers are free to pivot inside the outer race, so these bearings can handle considerable misalignment. However, this aspect of their design also gives them low accuracy when compared with other bearing types. Well, there's your introduction to anti-friction bearings, their basic function, construction, and the main types. And that's it for today from the Machine Tech video blog. I hope you learned something.